Hello, today we will be exploring how to solve exponential equations. The first case we are going to learn about is when the bases are the same on both sides of the equation. For example, 2 to the power of x equals 8. Here we can convert 8 to 2 to the power of 3, because 2 times 2 is 4 and 4 times 2 is 8. So basically we can make both bases the same. The bases are 2 on both sides, so we can conclude that x is going to be equal to 3. So that will be the first example. We can solve a second example. In which we have this. We can write 3 to the power of 2x equals 27 to the power of x minus 4. Now again, we need to have the same base on both sides of the equation. So we have to convert 27 into 3 to something, to the power of something. It will be 3 to the power of 3. Okay, so if we see a 3 on the left, we know that on the right we are looking for the same base, which would be 3 to the power of 3, which is 27. 3 times 3 times 3 is 27. And this is raised to the power of x minus 4. Now both sides are starting to look the same. So now we have to multiply this 3 times x minus 4. Okay, 3 times x minus 4. 3 times x is 3x. 3 times negative 4 is negative 12. So this equation will look like this. 3 to the 2x, which is the left side, equals 3 to the 3x minus 12. Now that we can clearly see the two bases are the same, right? The 3's are the same. We can say that the exponents have to be equal to each other. So 2x has to be equal to 3x minus 12. Now we solve this by subtracting 2x on both sides. So here we get 0, and here we get 1x minus 12 equals 0. Now we have to add 12 on both sides. So these guys cancel, we get 0 there. And here we have 1x equals 0 plus 12 is 12. So that will be the answer. X equals 12. In this case, the bases are going to be different. We'll see. So look, we have 2 times 7 to the power of 3x plus 1 equals 48. So the first step is to try to get rid of that 2 here, right? That 2 that is on the left. So we can divide both sides by 2. So these guys become 1. 2 divided by 2, 1. And 48 divided by 2 becomes 24. So basically what we have is 7 to the power of 3x plus 1 equals 24. That's what we have. Now, when the bases are not going to be the same, because here you can tell the bases on the left are 7 and on the right, well, you cannot convert this to 720 power, right? It will be 6 times 4. So in that case, what we do is we apply logarithms on both sides of the equation. Okay, so we do this. We're going to put logarithm here and logarithm here. Okay, so let me rewrite this so we have some more space. Again, this would be 7 3x plus 1 equals 24. And I said because the bases have no chance of being the same, right? There's nothing I can do to make the bases the same. I'm going to apply logarithm on both sides. Now, every time you apply logarithm on both sides, you can take the exponent and move it here, because that's a property of logarithms, right? That you can move the exponent multiplying the whole logarithm. So that's what we are doing here. We move that 3x plus 1 multiplying log of 7, and that would equal log of 24. Now, what we do here is we divide both sides by log of 7. So these guys cancel, they become 1, and here we have 3x plus 1 equal log of 24 divided by log of 7. Okay? So now we don't worry about this whole thing. We will put that in a calculator, but first we have to find the value of x. So we just subtract 1 on both sides. I subtract 1 here, I subtract 1 here. So this becomes 0, and here we'll have 3x equals log of 24 divided by log of 7 minus 1. And finally, to get the x, we have to divide this by 3 and this whole thing by 3. So x is going to be equal to all this expression. If you put it in a calculator, you can put parentheses in here and get a value from the calculator. Okay, that'll give you a decimal. So yeah, that's how you solve an exponential equation when the bases are not the same.